Hi, Paul. Good to see you.
Excellent. Welcome everybody. Good morning, good afternoon, good evening to those of you joining our WHWB noise course. Together we are starting our fourth session today on 8th of March 2023. You have your co-hosts having their cameras on, joined by Gary as well. And as well, we are going to have our fourth session being started today. Gary, if you'd like to kick it off with the topic, and if nobody has any questions, let's start.
I'm actually going to hand this right off to Peter, if he's ready to go.
Oh, Peter, sorry, I apologize. Why did I say Gary?
Yeah. Right, I should be sharing my slides. Something says slideshow. Slideshow, come on.
Showing.
From beginning, here we go. So what we're looking at today is how to control noise in workplaces. It's pretty much an overview of the topic. Obviously, there's a lot more detail. You can participants enable closed captioning. Oh, that's okay. So it's pretty much an overview of the topic, and there's obviously a lot more detail underlying what we're going to talk through today. Well, here's an outline of the session itself. I'm going to talk about how noise gets transmitted. Because you got a source, and then a pathway, and then a receiver. And it's by knowing what these transmission routes are, you can put in the exposure controls to actually reduce the amount of noise that someone will actually hear in the effect. And by controlling it at the right levels, you should be able to ensure that people are not exposed to high levels of noise which will damage their hearing. And then, obviously, as in any control measure to anything, some things are more effective than others. And so I like to talk about the hierarchy of noise control. And the higher up this hierarchy you can go, the more effective the control will be. And also, it's an easier way to control it, say, at source compared to control at the individual level. And then just look at some forms of noise control. Just mentioned at source, so reduce the amount of noise that's being produced by the machine, etc. And then adjust its transmission routes. And then hearing protection. Hearing protection tends to fail for various reasons. And also, if you're not wearing hearing protection, there is no protection. So it requires a great deal of management. So just looking at noise transmission, you've got a source there on the left-hand side. So in terms of controlling the noise levels that someone receives, you can modify the source so you can reduce the amount of noise it produces, and that can be done by buying quiet. And changing the process, putting silencers on things. You can redesign the process so the noise is not produced in the first place. One example that might be instead of using a metal hammer to bend metal, use a rubber hammer, and that would reduce the noise by redesigning that process. And also relocate the noisy job, the noisy part, and into a different part of the factory, or relocate the individual. But in this case, we're looking at the source, so relocate the source into a segregated room, and then so those are how you might affect things at the source side of things. Then looking at the path, this is how the noise actually gets transmitted through the air. So you can put the noise source in an enclosure, so put it in a box. One of the problems you have with that is the noise inside the box can be quite significantly louder than it would be without the box. So that also means you can put some absorption materials in there. So this is basically material you can put in that will absorb the sound and deaden it. You can put that in the actual box itself, or you can put it on surfaces. And the other one, another very good technique is to put a barrier up. And by this we mean basically a wall of some descriptions between so the direct sound from the individual, from the source to the individual, it has a barrier in there and it stops it. And then looking at the receiver, you can put the worker in an enclosure as opposed to the sound. You can relocate the worker, put some absorption material around them, put them in hearing defenders. These are all valid techniques. But the main aim, obviously, if you control it at source, it's a much better control than controlling the path. And the one that's most prone to failure would be putting protection or PPE of some description on the actual worker themselves. So just having a look at the hierarchy of control. I'm sure we've all come across this in terms of chemical exposures, and this is another way of looking at it in terms of noise control. So in terms of noise reduction, the most effective way is to get rid of the source, eliminate it, change the work process, substitute it for something else, design it out. So if you're needing to have, say, metal, but need to bend some metal, you can sort of like design it out at the start and say, well, instead of actually bending the metal, we can get two pieces of metal and weld them together. So substitute the actual process. And then engineering controls, and this is affecting the path. And this is by just stopping the noise from being transmitted to where the receiver is. And then you've got administrative controls and the hearing protection. And this is basically making the individual do something. So minimizing the time they're in an area, making them wearing hearing protection devices to cut down the amount of noise that enters the ear. I'm sure you can see from this, if you look at elimination, that has a great potential to be the most effective way of doing it, because you basically got rid of the noise source, so there will be no noise problem. Then you got effectively the substitution, which is not quite as good because things can go wrong with that. Engineering controls, you're not really controlling the noise source, you're just controlling its transmission, which is not, it can be effective, but also it might be prone to failure, and because of maintenance things are going on there. And when you're talking about the individual, the receiver, and this exposure reduction side, that is the least effective of the lots. For instance, I think one of the homework questions was, if you remove the hearing protection device for 5 minutes, how does that affect the actual hearing protection you get from your hearing defenders? And we'll look at the answer to that one later on, but I think you'll be surprised at the answer, because it is quite a significant reduction in protection for just taking them off for 5 minutes for every hour. So these are prone to fail. So talked about this, and looking at the control at source, so reduce the amount of noise that's being produced. Design it out. Do you need to do a noisy process? Is there some of the work method you can do? I mentioned welding, as opposed to bending metal. It's a very, very good control. Buy quiet policy. So when you're buying machinery, look at the amount of noise it produces. You will find that machinery comes with details of how much noise it will be expected to make. So it could be as time goes by, you just replace the machines with quieter machines. Reducing the speed of the machine, that can have quite a large effect on the actual noise levels. And then there's subtle things like on saws, you can get low noise saws, and they have an S-shaped cut into the actual saw blade itself on the big circular saws. A little less cut in there, and that does significantly reduce noise. Maintenance is very important in this, because a sharp blade, for instance, may produce less noise than a blunt blade. And also maintenance of bearings, etc. So just general maintenance of the machinery to make sure that it is working as intended. Looking at the reduction at the path here, as I said, adding barriers. So basically put a wall up of some description, and that could be quite effective if the worker's behind the wall. And when I say wool, it might be just a mobile piece of what you might get in an office, say something of that ilk. Just a little barrier you put up between desks. That's quite effective at just reducing that low-level noise in offices. And similar sort of theory can be applied in a factory or other noisy processes. Putting the equipment in an enclosure can be very effective. But as I said earlier on, there can be higher noise levels inside the actual enclosure. So we can get around that by putting some absorbent materials, so the noise is absorbed and to reduce its transmission path. And that could also be a case of putting off reflected surfaces, because noise does get reflected off hard surfaces. So if you make the surface soft by putting these absorbent materials on, you stop that retransmission and that reflected noise. And we've also already spoken about reduction of the receiver, so limiting working time, relocating the employee to another part of the factory if they don't need to be there, etc. So those are some common control options. Here's an example of a total enclosure. The problem with total enclosures is you have to get your materials in and out. So you're always going to have holes, and those holes will actually allow the noise out of that enclosure. So you could end up with noise still being produced from machines if it's not been very well designed. Just looking at this picture here, you've got a little conveyor coming in from the right hand side, and as you can see, it's just a hole in the wall there. One of the problems with that hole in the wall is that will allow a lot of sound to escape, and you can put a tunnel on that, and that would massively reduce the amount of noise. And then other things you can do at source is, for instance, replace metal parts with plastic parts. So if you got, shall we say, a canning factory where you got loads of metal tins on a conveyor belt and they're all bashing into each other, you can restrict that noise by just instead of using metal guides for the cans, just replacing those with plastic ones, and that will reduce the amount of noise that's produced. Then we have a look at the engineering controls, and I'm just going to touch on some of these, because you've got the absorption. This is when the noise is absorbed. Insulation, generally speaking, the more dense the material, the barrier, the less likely it is to get secondary vibrations or retransmit noise. Distance. As a rule, the noise levels will fall as 1 over the distance squared. So we're doubling the distance, you quarter the amount of noise. However, distance is not doesn't quite work like that, because there's other sound sources going on there. As I said, reflections, reflected off surfaces, etc. So it's not quite this inverse square law. But generally speaking, the further you are away from the noise, the slight you do get a noise reduction level. But the fit silencers, if you got pneumatic systems, you can, when they expel air, they can be quite noisy, so you can put a silencer on them. Think about when you're on a car, on the exhaust has a silencer on it, and the cars are generally quite quiet, but if there's a hole on the on that silencer in the car, or it's fallen off for whatever reason, the engine can be very, very noisy. And same's true with noise sources. Putting on these silencers can be quite an effective way of doing it. And vibration isolation, sometimes you'll actually find a machine will vibrate the entire building, and that produces noise. So you can isolate the machine from the actual floor and the walls of the building, and that could reduce the amount of noise. And similarly, if you've got panels which are loose because of poor maintenance, they can act as a sound source in themselves. So putting dampeners on panels and making sure they're tight will reduce the amount of noise that's produced. And that's vibration isolation. It's also tends to be called dampening. So what we got here is a noisy machine on the left hand side, and then you got workers on the right hand side. So the one that's operating the machine is obviously he has to be there, he has to be operating that machine, so he has to be in the vicinity of it. But these other workers on the right hand side, I'm sure you can see they're just packing, so that's a quiet operation. So you segregate that out, put that quiet operation in a different part of the building, because they've been affected by the noise produced by this noisy machine. It's either direct, and you can see that big black arrow that's going from the machine horizontally to where they are, and that's direct sound. And then you've got the dotted lines, and this is reflected sound. So that's where the sound has hit a solid surface like a wall, ceiling, and it's reflected, and it's reflected again, potentially reflected a couple of times to where the actual workers are. These reflections can be controlled, and if they're controlled successfully, will reduce the amount of noise. So how do you control these noise sources? Well, put some absorption material in the roof and on the walls. So instead of when the noise hits the ceiling or the wall, instead of being reflected, it's just absorbed, and it's not retransmitted out, and it soaks up the noise, for want of a better phrase. And that means the workers are only, the workers in this quiet zone on the right hand side, they're only going to be affected by the direct noise transmission, because you cut off all the reflected sounds. However, you might find that doesn't really give enough noise reduction at that quiet workplace. So what you can do on this next slide is put up a partition or a barrier. Obviously there's some design criteria about the partition. It has to be a certain made of the right materials, the weight of it, the density of it will affect its effectiveness, and to an extent you also want to make sure it doesn't it doesn't itself become a sound source in itself, so it has to be isolated, etc. But by just putting that barrier up, you can see the workers behind it in this quiet area. They are going to have a significant reduction in their noise exposure. The other option, of course, is to put that barrier around the machine itself. So put it closer to the machine and control it a bit more at source. But that's not necessarily a very good approach, because what you can, if the barrier is the wrong size, you can get noise refracting around the side, so it just basically bends round the edges and over the top. So it's not a perfect solution in that sense. Dampening. I spoke about this, and one way to look at it is if you look on the right hand side, what you've got is a machine that's producing vibrations, which will produce noise, and it's directly bolted onto something. So it could be a metal plate, could be the actual building, the building itself. But any vibration and therefore noise that machine makes gets directly transmitted into the building fabric, which then acts as a sound source. One thing you can do to stop that is to put some dampening on there, or as you can see, a steel washer, put some rubber on it, and that just isolates it from the building, and it stops that transmission. Another way on the if you look at the left hand on the right hand side is where you're dropping things off a conveyor. If you're going from the conveyor drop, and it's got on the top one there, you've got a fairly large drop before it hits the funnel, and the funnel hasn't got any coating on, so you got a large drop, means there's a lot of energy going on to effectively a steel plate, which is going to make a lot of noise. And the way you control that, if you just look at the bottom there, is you minimize that drop height, so you really minimizing the amount of energy that you're putting into that process, and then you can actually put some rubber or something of a similar ilk on the actual funnel itself, and that would reduce the amount of noise that's being produced, and this can be quite effective. One thing you have to watch out for with these dampening systems on these funnels is wear and tear. So you have to replace them every so often and make sure they're still there, because they will wear. But it's a very good way of reducing noise. And now I'll just really want to delve into hearing protective devices, or hearing defenders. There's lots of questions around these. What type? There's two main types of hearing defenders available. One's an ear muff, which is basically like a cone that goes over the pinna or the ear itself. And the other one is basically a plug you put into the ear canal. Both have their advantages and disadvantages. For instance, the one that goes into the ear canal is invariably not used correctly. The number of times I've seen this, people wear them incorrectly. Oh, thank you, dear. Sorry, I just got a cup of tea from my other half, so I must apologise then. But these in-ear types, as I said, they tend not to be worn correctly, so there's an element of training and supervision required. And also, if they're reused, they can cause ear infections. And in some individuals, people just don't like them. Yeah. Now the over-ear ones, you think, well, they're quite nice, but they rely on a tight seal of the foam against the wearer's head and around their head, which means if you've got a lot of hair around your ear, it can affect that seal and therefore affect its performance. And also, I can say, based on experience, they're quite nice in the winter when it's nice and cold, because your ears get quite warm. But in hot climates, they can cause issues because they're too uncomfortable to wear for a long time, because your ears heat up. And so these, some of the pluses and minuses of each one. Protection factors. I mean, how much sound do you want to reduce it by? What are your measurements, and what do you want people to hear? And that protection factor is quite important. Now, some of the homework I gave you was to look, just make you aware of the different factors, because you got the single noise reduction factors, which is a single number, or you can do octave band analysis to determine what if the hearing protector you've got from the manufacturer's data would protect you against the noise levels and the frequencies you're experiencing in the workplace. And what locations? Where do you wear it? These have to be clearly defined and enforced. And then you got other factors to be considered, like wearability. How long are they going to be wearing it for? Is communication going to be an issue? And then looking at the usage, over the years, I've seen people being told to wear, like I say, hearing defenders, and not wear them, or not wear them all the time. And that can have a significant effect on the protection they offer. As I say, the training side, these in-ear ones need a lot of training to actually put in correctly. So there's training and training with that, and then on the over-ear ones, there's training in looking at the maintenance thing, the maintenance side, because they are reusable, so therefore normally cheaper. But as time goes by, the foam, the seal can get a bit hard and it doesn't work properly. And also, people might take out the material, the dampening material, the absorbent material inside them. I have seen people take out the absorbent material and put, say, cigarettes in there, because that's what they do. Which brings me nicely on to the last one about maintenance. They need to be, if they're reusable, they need to be maintained. And maintained appropriately, as according to the manufacturer's instructions. So just have a look at these. It's all like I said, we've got the in-ear type, or the inserts on the left there. And as I said, these do have their place, and in warmer climates, they might be preferable to the type on the right, which are reusable, these over-ear type. These over-ear types can be quite sophisticated, because you can have effectively a little microphone that measures the noise outside, and it does, and then it produces anti-noise to knock it down. So it's active noise reduction. And sometimes you can, as in this case, you can see that those earmuffs have got a radio built in. So if you need communication, you can have that radio built into the system, so you can hear what the instructions have been told. Shall we say, if you're in a really noisy environment, that might be the preferred choice. And sometimes, if you're in really noisy environments, you might need to wear both. And in something that goes into the ear canal and the muff type. So,
Peter, there's a question in the chat with regards to the noise reduction expected from the engineering controls. So is there like a study expecting or estimating the noise reduction with each of the engineering controls, like encapsulation or dampening or whatever?
The short answer to that one is there are some guidelines. However, it's not necessarily just about putting the dampening materials on. It's about getting the right type and making sure they're maintained and they're correctly designed. So, as with everything, a competent person should be able to help with that, and help with that decision-making process. But there's no one answer I can give you, because it's situation dependent. So that's just unfortunately the way it is. I wish I could say something else. Right, where am I? Then looking at the selection, I talked about the various systems. You've got the octave band analysis, and this is kind of like the gold standard. And this is where, when you do exposure measurements, you're measure it in octaves, and then you would apply a look at the hearing defenders you're thinking about using, and then see what the reduction factor is for each of these octaves, and then you really are specifically tuning it to the actual noise that's being produced. Has its place. The majority of time you can get away with this SNR system, which is single noise reduction. So your hearing protection device will have a single number, and then you measure C-weighted noise as opposed to the octave band analysis, which is a lot simpler. But because you just measure it and then you just look at that C-weighted noise measurement, then you apply this single noise reduction factor, and that tells you if you're going to end up with the appropriate amount of noise protection, hearing protection. So you're not overprotecting or underprotecting. Both have issues. If you're underprotecting, you're still being exposed to noise, so you're still going to get hearing noise, noise-induced hearing loss. And if you're overprotecting, you might find that people have issues just looking at the hearing emergency noise, emergency alarms, road traffic, if you're walking around a factory, and you might feel isolated as well. So overprotection is a big issue with hearing defenders, and the HML method. This is kind of like a mixture of octave band analysis and single noise. With the HML, you measure A-weighted and C-weighted noise measurements, and then the manufacturer will give you three protection factors. One's for the high frequency noise, medium level, the mid range, and the low frequencies, and then you can put those into a spreadsheet effectively, and it will tell you if your hearing protection is adequate or not. So now on to my breakout questions. And really, in the rooms, I want you to sort of like just talk about your experience of noise control, and what have you been your successes, and where have your failures occurred. Now looking at this, if you say about 15 minutes or thereabouts. So I'll stop that. Is someone going to put them into breakout rooms for me?
We could do that. There was another question, Peter.
Oh, yeah, I'm sorry.
And the question was, I can't find it now. Is there a formula to convert dBA to dBc, considering noise measurements was done in dBA and HPDs has the single noise rating?
The answer to that is no. Because the actual measurement itself is when you take it, it's already been weighted. So C weighting is effectively flat. So going from the over all the frequencies, it's effectively the same response. With your sound level meter has the same response across the entire range. Whereas the A weighting, it's a bit more weighted at the bottom and the top, so it's not flat. There is a curve, and the A weighting measures things according to how you would hear things. So it's looking at that frequency weighting. However, if you've actually done octave band analysis on your meter, you might be able to de-weight it, but effectively I'll turn around and say, when you're doing the measurements, measure A weighting and C weighting, and then that way you've got all the measurements you need in 90% of the cases. Like I say, octave band analysis, very useful, very powerful, a bit fiddly to use, and it's a bit more time consuming. Yeah, so hopefully that's did that answer the question?
Thanks. The other thing too is if you may have a type of sound level meter or noise dosimeter where you have like 2 separate meters on it. The more sophisticated one have that, and you can do a setting. So one of them is measuring dBA and one of them is measuring dBc. And that's very useful for this. So we call that, if you have a sound level meter or noise dosimeter, that will do that. It's helpful.
Right.
So I know you have the quiz questions, but why don't shall we do the breakout rooms and then
I think we
come
do the
back?
breakout rooms, then we can come back and
first.
go for the quiz
Okay.
questions.
Right, and I'll just stop your sharing if that's okay.
Yeah.
Okay, thanks. And if I don't know if there's any other questions in the chat. Yeah, so I put the breakout question in the chat. So I suggest that you copy it so you can put it in your own chat box. And let's see, well, let's still do 4 breakout groups. And Gary, can you stay for the breakout group and be one of the people in it, or?
Sure.
You can. Okay, good. Then we have enough co-hosts for each breakout group, and I can still stay in the main room to help anybody who doesn't get in. So I'm just going to make sure that we have a co-host in each room.
Yeah.
I don't see where Peter landed. Peter. Oh, we have 2. Okay, I'm going to move you, Peter, to move to 4. Okay, I think we have a leader in each, co-host in each room. If that's wrong, I will fix it after we open the rooms. So here we go. Please accept the invitation to the room when I open the rooms. And how much time? 15 minutes? Is that about right, Peter?
Yeah,
maybe 10.
Yeah, about 10 to 15 minutes.
10, maybe
we'll see how the
12 minutes.
discussion
Come
goes, I
back
think.
at 10 minutes to the hour. I think
Yeah.
that would be fine. Give us 12 minutes. Okay, here we go. Okay, the people who are still in the room, could you accept the invitation? Paul, good, great, okay.
2 years back, we have a mining contractor here who is used to haul the material from the pit to the dumping point. So there was one excavator operator who was diagnosed with noise and hearing loss. So we went there to do the investigation and the measurement. But the critical point that we identified with most of the mobile equipment was that the cabs were broken. Most of them were broken. And also the air conditioning system in the cabs were not functioning. So sometimes the operator, they lower down the doors or they open the door while they are loading the trucks. So during that period, they are exposed to very high level of noise in the pit. So that was one of the cases that we found. So the engineering control in the trucks or in the excavator were failing. So that contributed a lot to that case. And also we have had another case in a process plant. We have many operations around Africa, but in this case, it was both for noise and dust. So in that process plant, we were confronted to an accident to noise and also dust. So what we did after implementing dust sprayers in the process plant, we also built some small houses or some small rooms within the process plant where the operators can stay. And from time to time, they'll go out and check and come back into that room. So we also implemented that in that process plant. And the last one was just last year. We received another contractor who is supplying us with power. They generate power for us. So they brought some new generators that was creating a very high level of noise, and they were also installed near to a pump fuel station, where the pump fuel attendants also were complaining about that noise. So what we did, we built a kind of wall between them. But after that building, we check still the noise levels were not at an acceptable level. So what we did is that they will switch them on at the night where nobody is around, especially the pump attendant, and when it's daytime, they switch them off. So we end up recommending that.
Very, very rich examples from Dabi's mining industry, and thank you so much, Dabi, for that. There were two other examples as well shared from different industries. One where they were relying on previous dosimetry and noise map results, where the noise map showed the sound level to be below 80, and it was presumed to be maintained at that. When doing the medical monitoring program, it showed up with an employee that had a permanent threshold shift in the graph. And going in an investigation and tracking back, they identified that the noise map did change, and it was indeed 87. And the employee was not wearing any PPEs. And that was the root cause for that. That was shared by Dr. Mohammed. And there was another example as well. I think it was two shared as well, that convenience of wearing PPEs in hot countries is an extremely important factor with adoption. People may not be adopting the PPEs and wearing them constantly if it's an inconvenience. If it's too hot, you cannot wear earmuffs, for example. If you're relying on the plugs and you need your fingers to crush them, however, your fingers are dirty and you crush them and you insert it in your external ear, you get infections and so forth. So convenience is an extremely important factor when considering adoption. Thank you very much.
Really good points. Wow, that was great. In the interest of time, we probably need to go on to the next group. Chandra, you were in that group. Did you have someone you wanted to report, or did you want to report?
Yeah, I'm just waiting if someone wants to volunteer rather than me saying what we discuss. Yeah, I guess no one. I think we have a good contribution from everyone actually, and we looked at one example of elimination where in the mining industry the automation actually has reduced the exposure to noise. The second example was of engineering control where someone shared about the use of acoustic material and the silencer to reduce the exposure to noise, as well as one of the mining industry experience of putting a barrier between the processing of manganese mining work from the operators, reducing the transmission of noise. It was interesting. There was a conversation around the use of hearing protection and the difficulties with that. Some of them Tamer has already highlighted, but one thing we discussed about communication problems. So in those mining industry and any other work settings, people have to talk with their colleagues, their other people, and not all the hearing protection devices come with those inbuilt communication tools, and that affects the protection provided by those hearing protection. So people who take their hearing protection, remove them to talk with others, and then put it back, which affects the effectiveness. And also someone shared about the difficulties in using the hearing protection, and apparently the low frequency noise gets amplified when using the earbuds, the in-canal hearing protection. Now, I haven't come across that. Peter might be able to comment on it if that really happens. But those were a kind of discussions quite useful we had in the group.
Peter, did you have a comment on low frequency noise and hearing protection?
Either. It can protect against low frequency hearing protection, can protect against low frequency noise, but there comes a stage where the frequency is so low it doesn't affect your hearing, and it's more of a whole body vibration type issue. And that has whilst it doesn't necessarily affect your hearing, it can affect your sense of balance and stuff like this. So it's more, it might be moving more into physiological issues rather than hearing issues, if you see what I mean. but hearing protection should go down to about, trying to remember now, it will go down to about 400 hertz, somewhere around there, up to about 16 kilohertz. So that's kind of like where the hearing protection will work. But like I say, it's the lower frequency noise is harder to control than the higher frequency noise.
Great. Thanks, Peter. We should go on to group 3. Gary, is there anyone in that group that you would think will report?
If Hussein is still with us and wants to share, that would be great.
Yeah, he seems to be here, Hussein.
Right. Yes. So we had a good discussion, and I think most of the participants were on the same line that in this part of the world, sometimes it's very difficult to suit the elimination method and engineering method. So most of the time we end up relying on administrative controls, limiting the time of exposure, and mostly heavily relying on the HPDs. And also it's been challenging on the compliance to wearing HPDs. And we also gave an example for mining industry, also example in the garage where people are exposed to compressed gas, but also the community noise exposures, like we're working like the machines, etc. So those are kind of things that we discussed. Thank you.
Great. Thank you.
Yes.
Thank you, Hussein.
Yes, I
That
have
was very good.
one more example where an engineering they tried to implement some material for acoustic dampening, and it turned out to be not as effective as advertised.
Interesting. Yeah. Thanks. And group 4, that was your group, Peter.
Does anyone want to feedback from the group? Yeah, stunned silence.
I'll report in terms of the group. It was a fruitful discussion, and we had almost all the group members had some experience in terms of noise control. A case was given whereby one of the guys, the Stendai, who works in a lubricant factory, and there were pumps. These particular pumps were generating noise in the production line, so they had to redesign the workstation, and then they moved the pump station outside the production line, outside the factory, and then they enclosed the pumps. That really reduced the noise levels in the factory. And also an important discussion point was not to have a blanket approach to noise control. It has to be specific, because once you have a blanket approach where you are giving everyone hearing protection devices, that will lead to the employees really not getting the importance of using such. But then if it is specific to noise zones that are actually where you have performed the occupational hygiene measurements, and then the specific machinery in areas that produce noise, that's where you focus on. That's the risk-based approach to noise control. And also critical is the selection of the hearing protection devices, the hygiene part, and then the maintenance. Because an example given by Malebina there was where they had a custom-made hearing protection devices that had to be maintained annually. But due to resource and then lack of the personnel to actually maintain the device, they went on for quite years without maintenance, which then gives a false protection to the employees. And also an issue alluded to by Doc, whereby hygiene is critical, especially where you have employees working in in a dust environment, and then they have the earplugs that they actually have to fold and put it in their ears. Yeah, I think that's about it. To summarize, I don't know if any group members would want to add one or two issues.
Great, thank you so much, Tafadzwa. I'm wondering if we need to go on, because Dr. Tamer was going to start a new topic that's sort of a lead into next week. So Peter, if you want to finish, I don't know if you want to do the.
Yeah, I'll just
yeah.
finish off with the
Yeah.
the feedback from the pre-course questionnaires questions. So I'll just share my screen. So this is the question about what are the problems about using HBDs compared to noise engineering. And so basically, if you're looking at noise hearing protection devices, you can end up with isolation type issues because you can't feel you can talk to people. Communication with the people might be an issue because you might have to shout so they make them hear, so they can hear what you're saying, and they may not use the devices. So the correct response here was all of them. So well done everyone that got that one right. Well, let's go on to the next page. Now this one's about if you remove your hearing defenders for 5 minutes per hour, what's the effect of the exposure? And the answer is it reduces from 25 dB reduction down to about 10. And that's just removing it for 5 minutes every hour. I was listening to somebody else earlier on that was talking about the noise enclosure in the truck, and when the worker opened the door, they get quite a large amount of noise, and that is going to be a similar case to this, because you open your door, if your noise enclosure reduces noise inside the cab by 25 dB, you go open the door for 5 minutes, that protection drops down to about 10. So you can use that calculation there. And that's just a link down here to let's see if this will work. Can everyone see the web page there? No.
Well, we just see the slide. We clipped it from the slide.
Yeah.
So this was that web page. If people want to check how we got that answer.
Yeah.
It was from this web page.
Yeah. If you look on that web page, there's a little slider, and you can move it from left to right and see the effect of changing the removing your hearing defenders for 5 minutes. That's the effective protection you get is 11 dB. And obviously, if you remove it for a whole, don't wear them at all, you get 0 protection. So a very small usage time, not using it for a very small amount of time, has a massive effect on the protection factors you're getting from these hearing defenders. And I'm glad to say everyone got this one 100% right. So well done, everybody. So it's effectively source, engineering, controls, hearing protection and training in that kind of order. So it's just asking about that hierarchy of control. So I think without further ado, I'll stop that sharing. So it's over to yourselves if you've got any questions, or we can move on to the next session.
Great. So thank you very much, Peter. And Marianne, if you'd like to do the honors and share from your end, that would be great. Marianne, I think you're frozen, right? Okay, so with that, let me try. I'm not quite sure if there might be an issue with Marianne's presentation. Chandra, could you help out if that's possible? Do you have the slide deck? while we're sorting out the technical issue, we're talking in the next session about medical monitoring, and especially with the audiology. So just roughly, how many of you have seen that happening? Raise of hands. You know how to raise hands down there in the reactions. You can click once onto the raise hand and then click again to lower the hand. So how many of you have seen? That's good. Somebody is already excited. Yes. How many of you have seen or have medical monitoring in your facility? So just to get a sense, that's good. 4, 5, 6. I can say yes for myself as well. 7, 8. Yeah. So a fair number of people have it, but not a lot within the group. So that's a healthy way, and that's good, because medical monitoring, when it comes to audiometry, is extremely important, and it helps a lot with the employee, with the company, with the productivity, and with many things. Marianne, welcome back. Marianne, can you help us with the sharing of the slides?
I'm back. I lost my connection. I don't know what happened at the end.
That's perfectly fine.
Okay, so where are we?
We're just starting. If you can just pop up the slide, that would be great. Thank you so much.
Okay, so the slides for the that you were going to show, right?
Yes.
Yeah, hang on 1 minute. I had them all open, but now I don't. So.
Oh, okay. The force restart. All right.
Yeah, hang on.
So we were asking while you were away about people who have audiometry in their facilities, and we've had a small number of people show up hands, which is so nice. Within, I would say, 24 participants or so, like maybe 10. So almost half, which is still a good number. Yeah, with facilities that have in-house medical monitoring being the best, that's because it standardizes the machine that does the measurement. It also carries a burden of making sure that we do adopt the proper measures of making sure that we are having the right calibration and the right measurements in place. So with the hearing conservation and noise control program, in the next session, we will cover a good number of in-depth topics, including, but not limited to, the policy, roles, risks, the engineering, maintenance, purchasing, noise control, hearing protection that we have touched base on, the surveillance, hazard, communication, worker training, evaluation, and record keeping, which is extremely important and influential, and helps protect yourself and your company against litigation. So next, please. We're going to do the poll question.
Right. Yeah. So this is the poll question, and I'm going to launch the poll.
Exactly.
I can launch it while the slide's still on.
So
yeah,
in your,
there it is. Yeah.
Thank you. So you find now a pop-up noise control poll that is in your screen. Do you have a noise protection program in your workplace? So yes, a full program. Yes, we have some of the elements, and no, not at all.
Okay, I'm going to close it in a minute if anybody still wants to add your vote. Oh, still getting answers.
Yes,
okay.
That's great. And we're getting more answers.
And I'll share the results now. Interesting. Can you see the results?
Yes, so 40% not at all. 30% have only some elements, which is actually encouraging. And yes, we have a full program. That's also very, very encouraging at 30%. So thanks for those who corresponded. We can go on to the next slide, please. A noise program, one of the things actually that it does is it ensures the employees' health, longevity, wellness.
Yeah.
Sorry.
Go ahead, Tamer. I think the rest of them were for next week. Did you still want to do this?
No. That's, yeah,
Okay.
that, yeah, exactly. So basically, we'll talk just the generals of having it, the importance of having it, the program, I mean. So with a company that has a program, a full-fledged program, you do need to have a proper design. And in order to have that design, you need to be very open and working transparently and closely with both your leadership, your health HSNE team, health, safety, and environment team, and also make sure that you identify the proper people who are to be included in the program. In that, your program needs to link very closely to the example. Remember the example of the people assuming they were in a low noise area? You need to have a structure of making the dosimetry or the noise measurement frequently. Be it some plants have it every quarter, some plants have it every half a year, 6 months. So you need to make sure that this is being done in an accurate way all around the machine where people are standing in different hours of the day. And based on that, you need to make sure that you are actually having the proper and only the exposed number of people being tested. Because if you actually open it up to everybody in the plant, you might be exposing your employer to unnecessary litigation. If somebody is not exposed to high noise and they're in an admin, and this, by the way, happened where I was working at one site, and they were admitting everybody without linking with HSNE. And one person came by and said, you know what, I've started to lose my hearing, and the results came up. And we were joking because this person shouldn't have done the hearing test in the first place. He is doing a desk job related to quality or whatever, and he doesn't even have a time-weighted average close enough to be included in the measurement. So these are examples whereby the proper preparation of the program actually makes the results much beneficial for you, your employees, and get the results to be meaningful. Another example basically for the benefit of the program is to ensure that people stay longer with you as an employer or as a company, produce more, be more productive, and the employee would be more happy with themselves, and they can actually continue to be productive within their working age rather than have to be limited within their working age. We have seen stories where people actually being requested to change their line of work simply because they have suffered a permanent hearing loss to the extent that they cannot hear the evacuation alarm. So it has happened, and stories like that are around us, and people may be asked because not to be employed anymore in the plant because they are too much of a risk to be employed anywhere, and they actually have to change even their line of occupation and change what they do best. So the program needs to be very well designed with HSN. The program needs to be very well updated in a periodic basis in agreement with your senior leadership and all the relevant stakeholders. The program needs to be well executed with proper announcements, education, making sure that the leadership buy-in and endorsement to your employees and to the clinic or the occupational health staff is in place. The occupational health staff conducting the testing need to be well qualified, and there are other agencies, not just, you don't need to be an audiologist or optometrist or whatever. You can be a nurse, you can be trained by different, or even HSNE can be trained by relevant organizations. I'm not going to say one or two, otherwise it will be an advertisement, but there are many agencies that you can get trained to do the program in-house and save money for the employer and the company So you can do a tailor-made program with the proper training, proper machinery, and all that is needed from you is to identify, screen, first of all, the proper people, identify high-risk people that may be starting to suffer hearing loss, and properly refer once confirmed. Properly refer. You're not asked to diagnose, you're not asked to do interventions, you're asked just to start an investigation, which is the first step, and request the necessary people to see what has gone wrong within the circle of control. So these are things that are very simple, cost efficient, anybody could do. Even in plants or places of work where you cannot afford to buy an audiometry device, have a cabin, have the training, you may partner with somebody nearby who has all of these. It can be a medical facility that offers this service. Just make sure that you are very close to the clinic. Make sure that they do calibrate their device on a yearly basis, and preferably even they calibrate it at least once a day when they are doing the testing, and you actually are part of making sure that this machine is maintained. Fix that place so that over the years you can actually get something meaningful, rather than have a reading here this year from this place and everybody's doing good, and next year you're actually using another medical facility and all the readings may be bad or whatever. So make sure that you fix the readings or the bearings or and the calibrations and the trainings and everything around it. There is so much more to speak about it. Basically, the process, the alignments, the cost, and the cost can be relatively challenging for some. However, the cost of having a single case of hearing loss and the lawsuit is definitely larger than a full year's program can cost a company or an employer in most countries of the world. So this is what usually is a buy-in in terms of getting leadership to who are slightly reluctant or slightly conservative and saying, no, we don't want to be doing this. You can convince them with that. I pause for any questions, if there are any, I see none on the chat, and since we're a smaller group now, I ask anybody who has any question from this part or today's part to please raise your hand or unmute or chat and share your question. Any of the co-hosts wishing to also give a closing word before?
Yes, I would comment on something. One is, you told that example of the person who had hearing loss, even though you did not think he was exposed or she was exposed to higher noise. And maybe people could just recall the slide that Gary showed last week that mentioned that the World Health Organization said that some people could have hearing loss even as low as 70 dBA, and certainly 80 is, there. It's pretty well recognized that people can have hearing loss if they're exposed to chronic exposure to 80 dBA, and that the exposure limit that's most commonly used, which is 85 dBA over 8 hours, is not really intended to protect all workers, unlike other exposure limits. So it is to be expected. I mean, if you think of the millions of workers worldwide exposed to high noise, there are many who will have hearing loss even at lower exposure levels. So that's why the program you're talking about, Dr. Tamer, would be really important, to try to identify people like that and help prevent it before it gets extreme.
Thank you for that, Marianne. And one of the aspects actually to consider as well, and it's also a footnote, when in investigations, make sure that you have a multidisciplinary panel from different functions, including medical, HSNE, even engineers or engineer controls, or even HR within the investigation to identify what had happened. How many was there a feedback system? Was there a proper training? Do people even know how to use a PPE? Because you might be surprised that people use the PPEs, know how to use it. They have been given feedback on not using it, yet it's more convenient. For example, remember the convenience bit about the heat that was given, and this is important. This is extremely important. With people need to be offered the convenient PPEs. You cannot offer earmuffs in hot countries or hot and damp places of work. You cannot offer the earplugs that you have to squeeze in areas that people have greasy hands. So there are earplugs that have an area, a holding area, other than the area that touches the ear. There are many solutions out there. There is the proper maintenance. There is the training. There is the training needs to happen frequently. There is no reason whatsoever to accommodate a noise-induced hearing loss case and say, yes, it's fine, it happens, it's a high noise area. It shouldn't happen. People should go home safe, just like the day they came into the plant. And that's the importance of designing a noise protection program, and including the measurement before exposure to noise, So as soon as somebody gets employed, you do the baseline testing. That's important. And you keep that in the employee's file that is stored and locked in your medical cabinet or medical file. So we will talk more about this. We will talk more about the filing. We will talk more about the testing, about what to expect, how to look at noise exposure cases, how to identify the readings. You're not expected to diagnose. You're just expected to screen, flag, and make sure that the employee is notified and that you follow through with the different functions for an investigation. So this is our righteous role as people who care about noise in the workplace. So with that, if no questions are... Yes, please.
I just wanted to add to what Dr. Tama mentioned about the lawsuit, because every workplace, like especially in a mining sector, they will have what they call segment exposure groups. So you have to know which groups are exposed to noise, and that those are the groups that you will monitor annually or every 6 months. So you will know that somebody who works at the office, they are not exposed to noise. And such a person presenting a noise-induced hearing loss, it might be that they are exposed to noise somewhere else for recreational or some other place. So it might be that somebody is there, they work with people who are exposed to noise, but for them, they are not supposed to be included in the monitoring because they are far away from the noise sources. So I guess, yeah, having those groups in the workplaces, knowing that this group is the one that needs to be monitored, this one is not supposed to be monitored.
Excellent, excellent. Thank you so much, Sina. And that's what comes into importance when we link and work very closely with health, safety, and environment. And we ask HSNE, identify, based on your latest noise map, who is exposed. These are the only names that will be included in the program. And then everybody else is not going to be offered this audiometry. You want to do it at your insurance expense outside of the program. This is not a free ride. So excellent point. And one point I wish to add as well, that each of us, including our colleagues, work for a certain number of hours a day. The larger portion of the day, be it 8 or 10 hours or so, the larger portion of the day, we have our private life. Some people might be listening to loud music. you would be surprised how many people like motorcycles, how many people like shooting guns, recreational shooting, or other high noise sports. This is to be included when we are investigating a case of noise-induced hearing loss. So these points need to come in the investigation. I think we've talked a lot. The subject is very rich. The material, and everybody is very enthusiastic to talk about. I'm really looking forward to meeting you next Wednesday. If there are no questions, we will stay a couple of minutes. And we thank you so much for attending. We wish you a lovely rest of the day, lovely evenings, sweet dreams if you're late at night. And thank you for staying with us. And we'll stay a couple of more minutes for you. Thank you. We can stop.
Thank you, everyone. Thanks, everybody.
We can stop the recording.